here. I'm going to do the geometry higher questions with you, starting with the first one here. Topic, so that you can read this, is linked to circle theorems. Okay, and I've established that straight away by looking at the question. I've been told some key information about and the fact that chord Q parallel to tangent TRU. Okay, it says calculate the size of angle E. Give a geometrical reason for each of your working. First, how do we start this question? Well, by given the fact that parallel lines, I know straight away that from this 66, this angle here is also going to be 66 degrees. And the reason for that is these are alternate angles within the parallel lines. I'm going to state that now with the reason, the geometrical reason for that. So, angle, and I'm going to use the letters here, R, P, Q, equals 66 degrees. I'm going to say the reason. Alternate angles are equal. So I've given the reason, the side. Next angle is this angle here, and I can E because the angle is a triangle. Now, this angle is always 60 degrees because alternate segment theorem means the angle of tangent is the same as the angle in the alternate segment. So these two angles are equal. So write that. So angle, this is PQR equals 66 degrees, and the reason for that is alternate segment these are equal. Now all I need to do is find angle E. So I'm going to write that down. Angle E, and simply the case that they're within a triangle, it'll be 100 degrees. Take two angles added together. That's going to be 180. Take away 132, which is going to be 48 degrees. And I need to give the reason for that as well. Angles in a triangle add to 180. Okay. So you're aware in terms of the marks for this question. You get all 5 marks for the 3 angles and 3 reasons. 4 marks for the angles, but only 2 reasons. 3 marks for the angles and 1 reason. 2 marks for the angles but 0 reasons. And 1 mark if you only got 1 or 2 of the angles. So it's really important that you can see that you state the reason with each of these. And the mark scheme is looking for alternate angles, alternate segment, and the angles in a triangle. That's what the examiner is looking for when answering and assessing a question like this. Okay, we're going to move on to question 2. Okay, now this topic here, the topic is vectors, and this is a challenging vectors question. It's worth 5 marks. Let's look at the detail that we have. We have O to A is vector A, O to C is vector B, M is the midpoint of AB, and L is a point on MC such that LC is 2 ml. So this distance here is twice this distance here. Okay, so key thing to know about vectors is vectors denote a direction. And whenever you're doing a vectors question, it's like going on a journey from one point to the other, and you're using that to describe what it is you're trying to prove. In this case, we need to prove that point L is on the line OB. Okay? And we can prove that by showing that the vector from O to L is in the ratio of the vector from O to B. If they are in proportion with each other, then that means that point L will be on this line that we have to state. So how do we go about doing this? Well, the first thing that we need to establish is how do we work out how to get to L from O. Okay, so that'll be my first thing that I need to work out, and I'm going to do that by actually working out what is the vector of this line here. How can I work out what M to C is? Well, the first thing I can do, if this OC is B and this is the midpoint, the first thing I can work out is that this part here will be half B. This vector to M will be half B, and I'm going to label that on the diagram there. Okay. Now I want to work out what M to C is. So first of all, how can I get from M to C? Well, let's have a look. I'm starting at M and I want to get to C. So how do I get there? Well, first of all, I'm going in this direction to A. So that would be the opposite of positive half B. So that's going to be minus half B. That's going from M to A. Then A to O. That would be minus A. And then O to B, to C, sorry, will be positive B. Again, it's minus A because it's in the opposite direction to the vector stated. I'm now going to tidy this up. So MC equals, well, you've got half B plus B. Okay, so that's going to be positive half B minus A. Okay, so that is the vector of M to C. I now need to work out what the vector is of M to L. Now I'm told that LC is twice ML, so this is double that distance. So what would ML be? It will be a third of this distance overall. Okay, so I'll make a note of that. I'll put it on the diagram here. ML is 1/3 of MC. Okay, now I know what MC is, which is half B minus A. That means that ML is going to be a third of this. Okay, so I'm going to do a third of this vector. Now, to help me with that, I'm going to use brackets first of all, and then I'm going to expand that bracket. Okay, so ML, I'm going to do a third times a half B, so that's going to be 1/6 of B, minus a third times A, so minus a third A. Okay, so let's just recap what we've done so far. We've worked out, we've added detail to the diagram, and we've worked out that MC is half B minus A, and the ML, so this section here, is a third of that, so it's a 1/6 of B minus 1/3 A. Now we're going to actually show that point L is on the line OB by using the vector that we found here. Okay. First of all, I need to know what the vector is of O to B. So to get from O to B, it's going to be A, vector A, plus the same as OC, so plus B. Now if I can show that OL is in proportion to this vector here, then we've proved that it's on the line. So now we need to work out what OL will be. Okay, so how do I get from O to L? Well, I'm going to go from O to A. then from A to M, so it's plus a half B, and then from M to L. Now I'm going to use my rule here. M to L is a sixth B minus a third A. Okay. Right, I just need to tidy this up now. Okay. So let's see what we've got. I've got 1A minus a third A. So I have 2/3 A. And I've got a half B plus 1/6 B. That's the same as 3/6 B plus 1/6 B, which would be 4/6 B. And if I simplify that, that's going to be 2/3 B. So I've now got the vector 2/3 A plus 2/3 B. So let me just put that together now so you can see it. And by showing that, you can see they're now in proportion to each other. OB is AB, OL is 2/3 A plus 2/3 B. So I'm now going to just combine those together and show that OL equals 2/3 of OB. Therefore, point L is on line OB. And I've proved that using the proportion there. Okay. Right, we're going to go on to the final question in this video. And it's this question here. And this is combining both sine and cosine rule into one question. So I'm going to write the topic here, sine rule and cosine rule. And the reason why I know that is by looking at this triangle. I've got a smaller triangle within the larger triangle here. There's no parallel lines, so I can't apply any angles in parallel lines. And also there's no right angles, so I can't use the rule to find either Pythagoras or the trigonometric ratio. So we are going to have to use sine and cosine rule. So a tip whenever you're doing this is to write down those two rules again, so you know which one to use. Okay. So a reminder of the sine rule is little a over sine big A, and the little a represents the side, and the large A, the capital A, represents the angle. So it's little a over sine A equals little b over sine B, and if you need C as well, it'll be little c over sine C. That's the sine rule. Okay. Reminder of the cosine rule. The one that I think is harder to remember. If you need to find a side, you start with a squared equals b squared plus c squared. And I always remember that bit because it's very similar to Pythagoras. After that is minus 2bc cos A. Okay? And that is to find a side, but you may also need to find an angle. So I'm going to write the cosine rule out again to find an angle. Okay? And it's a simple case of rearranging this to find cos A. So cos A is going to be b squared plus c squared, this bit here, minus the a squared, all divided by 2bc. And that's what you'd use to find the angle. Now, with both sine and cosine rule, you need to know how do you apply each of these to the question. You need to look for key things. Okay? When using the sine rule, you need two pairs of opposite sides and angles. Otherwise you can't apply this rule. So you need either a side and its angle and another side, or a side and its angle and another angle. Okay. To use the cosine rule to find the side, you'll notice within this, to find side A, you need the other two sides, B and C, and you need the angle A. So that means you need side, angle, side. Okay. However, if you're trying to find the angle, what do you need? Well, you need the three sides. Okay. So you need side, side, side to actually use that. That's really helpful with trying to think, right, what am I actually trying to work out here, and which of these rules am I going to apply? So let's actually see what the question wants us to do. It says calculate length CD. So I'm trying to find this length here. I notice I've got 28 here for AD, and I don't have this one here. I'm noticing as well I've got the opposite angle, okay, and I've also got this side length here, but I don't have this angle here. If I had this angle here, then I could use the sine rule, okay, but I don't have that angle at the moment. So what I'm going to do first is I'm going to work out angle DAE using the cosine rule. And let's see, can I use the cosine rule to get an angle? I need three sides. Well, let's have a look. I've got angle A, so this is opposite, this is going to be little a. And I've got these two other sides here, so they'll be B and C. So I can use this rule to find the angle DAE. So let's do that now. So I'm going to rewrite the cosine rule. So cos A. Now instead of B squared, I'm going to put my 28 squared. Instead of C squared, I'll put 41 squared minus A, which is going to be 22 squared. And that is all divided by 2 times B times B, which is 28, times C, which is 41. Okay, so I can now apply this to find cos A. So I'm going to use my calculator. I can use the fraction function here, so I can put it into one calculation. So 28 squared plus 41 squared minus 22 squared, all divided by 2 times 28 times 41. Okay, and I'm going to get my answer here. Now that doesn't give me the angle, and I need to use the inverse of cos to get my answer. So the inverse of cos, I'm going to do inverse cos of 283 divided by 328. Okay, and so if I apply that now, cos inverse, I'm actually just going to press the answer button to bring up that previous one there, which is just at the bottom here. Okay, and there we have it. So that's my angle for A. So that is going to be 30. We'll call that 30.4 at the moment for one decimal place. Okay, so I've got my angle. I'm going to label that on the diagram now. Okay, and now I've got a corresponding angle and opposite side, and I've got an angle and I need an opposite side. So now I can use the sine rule to work out what I'm looking for here. So let's use this side A to C. We'll label that as B. We'll put a little 2 next to it because it's the second B that I'm using. Okay. This angle A, 64, is going to be the opposite, so I'll put a little A2 there. I'm now going to rewrite the sine rule and use these values into that sine rule. Okay. So little b, so b2 over sine 72 equals little a, which I now know is 64, over sine, and I've got that angle, which is 30.4. Okay. How do I get b on its own? Well, I just need to times both sides by sine 72. Okay, and that's going to give me the answer for B, because I'm getting rid of this divided by sine 72 here. So let's do that on the calculator. So I'm going to do all of this value here and then times it by sine 72. So I'm going to use the fraction function again. Bring it this side so you can see. So 64 over sine. Now I still had the answer from before, so I'm going to use the answer button again. Okay, and then I've pressed the arrow across, then it's coming up here, times, and then we're going to times that by sine 72. So it's going to do that fraction times sine 72, and I'm going to get my answer there of 120.4. Okay, so B2 equals 120.401, etc. However, going right back to the question, we need CD, so we just need to take away this DA part here. So I'm going to take that away from my answer to get 92.4. So I'll write that down there, minus the 28. So CD is now going to equal 92.4 meters to 1 decimal place. Okay. So there you have it. Complex question combining both cosine and sine rule. You would get 3 marks here if you got to using the sine rule correctly. You then get 2 marks for the use of the sine.